The order of operations is a convention for determining the value of a numerical expression. The purpose of this convention is to ensure that every person and machine reads and computes an expression in exactly the same way and obtains the same answer. Sometimes we write this as Pemdas, as an acronym, P-E-M-D-A-S. You'll notice that as I have it written here, I don't have it written in a strictly linear order. I have P-E, and then on the same line I have M and D, and then A and S. So the P, which is the first thing that we look at when computing an expression, stands for parentheses. So whatever is inside parentheses will be addressed first. Next, we have an E, which stands for exponents. So any exponents will be applied after whatever is inside parentheses has been simplified. Next, we have M and D, which stand for multiplication and division. And after that, we have A and S, which stand for addition and subtraction. Now, I have P-E, and then I have M and D written on the same line, and A and S written on the same line. And I have a line above M and D with an arrow over it, and a line above A and S with an arrow over it. The reason these arrows are over it, pointing to the right, is that when multiplication and division are both present, they stand on the same level, and so we work left to right. And I'll write that on the end here of this arrow, left to right. And I'll write it on the next arrow as well. So multiplication, even though when we look at Pemdas, it appears that multiplication comes before division, it doesn't actually come before division. Multiplication and division are at the same level, and similarly with addition and subtraction, they're also at the same level. So if we have both addition and subtraction, we'll work left to right, and if we have both multiplication and division, we'll also work left to right. So now we'll get started on a few examples to demonstrate this order of operations. The first expression that we have is 4 plus 6 times 3. So the first thing we want to do is identify which operations we have. We have an addition symbol, and then we have 6 with 3 in parentheses, so that those parentheses there are showing multiplication. Looking at our order of operations, we see parentheses, but there's nothing inside them to simplify. So we simply have addition and multiplication here. So, looking at 4 plus 6 times 3, according to the order of operations, I will do multiplication first. I will do that before addition. So 4 plus 6 times 3 becomes 4 plus 18. I compute 6 times 3 as my first step. And now I simply have addition, so I'll add 4 and 18 to get 22. Next, I have 5 minus 8 plus 10. We'll note that the operations here are simply subtraction and addition. And addition and subtraction are on the same level as far as our order of operations is concerned, so we'll work left to right when computing this. So 5 minus 8 plus 10 becomes negative 3 plus 10. I compute that 5 minus 8 first, and then with that single operation left, negative 3 plus 10, I get positive 7. In this next example, we have negative 12 divided by 3 times 2. Written without any parentheses. So looking at that, the operations we have are division and multiplication. And since multiplication are on the same level in terms of our order of operations, we'll work left to right in applying those operations. So negative 12 divided by 3 times 2 becomes negative 12 divided by 3 times 2 becomes negative 4 times 2, which then becomes negative 8. In this last example, we have 4 times the expression. In this last example, we have 4 times the quantity 3 plus 7 inside parentheses, which is then squared. So the parentheses here are going to be what we address first. And we'll notice that the 2 in the exponent is only applied to that 3 plus 7 inside those parentheses. So taking 4 times that quantity 3 plus 7, which is squared, we will first simplify what's inside the parentheses. So we'll have 4, and that 3 plus 7 will simplify to 10, so 4 times 10 squared. Now we'll address the exponent, so we'll take 10 squared and that'll be 4 times 100. We'll note that the 4 is not squared because of where those parentheses and that exponent fall. The squared part is only applied to the 10 here because of the original parentheses. So now we have 4 times 100, and as the last step, that'll simplify down to 400.